we are ready to use inverse norm to find z-scores, and we'll take a look at a few different cases now. So we know that when we'd like to find a z-score using inverse norm, we need to know the area to the left of that z-score. So later our data values won't always be z-scores. We'll start doing some applications, but for now we'll be looking for z-scores. And let's jump in here and go through our cases. So case one is, what if you know the area to the left of the z-score you're trying to find? And then it's going to be just a one-step process. If you know the area left of the z-score, inverse norm can give you that answer. So let's look at the example. So suppose we want to look for a z-score that separates the bottom 2% of z-scores from the rest. And we've got a sketch of that here. So we're looking for a missing z-score. I'm just going to put a little question mark next to it. Let me get rid of the calculator. So I'm just trying to find a z-score and the area to the left of it. So bottom always means to your left, top means to your right. So in this case, they want the bottom, the area to the left of it to be 2%. So the given information is that the area to the left of it needs to be 2%, which is 0.02. And then this will be the easiest case because there's no work to do. You just find z by entering that area to the left of it into inverse norm. And then inverse norm does require the mean and the standard deviation for your distribution. But because we're doing z-scores standard normal, the mean is 0 and the standard deviation is 1. So we don't have to type the 0, 1 if we don't want to. The calculator assumes that's what we mean. So we could enter the 0 and the 1 for the mu and the sigma. It's just that it's not necessary. It's the calculator default. So let's just go ahead and enter it, and I'll do it without the 0, 1. So inverse norm 0.02. And I'm going to continue to round to 2 decimal places. Just always pay attention to the rounding directions. But later in the semester, we'll do generally 2 or 3 decimal places. So I'm getting negative 2.05. And we always want to make sure our answers make sense visually here. So if it's a z-score, 0 is the mean in the middle, and this number is to the left of 0, so a negative value does make sense. So negative 2.05 does match that graph. And then always just remember that area is always positive. So the area to the left is 2%. That's the bottom 2%. Okay, so the second one, find the z-score such that 85% of z-scores lie to its left. So this would be saying find the z-score that separates the bottom 85% of z-scores from the rest. So different ways to say to your left. You can say to your left, or again, you could call it the bottom. Either way, the given information is the area to the left is known. They want it to be an 85% area, so 0.85. And then finding that z-score, you just enter that area to the left into inverse norm. All right, and then we'll see if our answer makes sense visually in a moment, but let's do our inverse norm, 0.85. And that's positive 1.04. So let's see if a positive z-score makes sense. So 1.04, just about at 1 there. So that's our z-score. And because that's a positive z-score, if I look at the area to the left of it, that area is more than 50%. So I'm always thinking about, is that bigger than half the picture or less? So I've shaded more than 50% of the picture. And that makes sense because we said we shaded 85% of the picture. So this area to the left is 85%. And I'm just going to add here, because we do this a lot, we talk about the left and the right. So if the area to the left of it is 85%, then the complement, the other 15% of the graph, would be to its left. So I'm just going to add one more thing here about that z-score. So the definition of percentile, so the percentile value would be the percent of data to the left of the value. So for the z-score, 85% of z-scores are to the left of it. So that's called the 85th percentile. And we'll review percentiles more, but we did those in chapter 3, and we'll see them a lot here as well. All right. There you go, case 1. So case 2, what if they don't give you the bottom percent? What if they don't give you the percentage to the left? What if instead you're looking for a z-score and they give you the area or percentage to its right? All right, so this is the one where you're going to have to first find the area left and then use inverse norm. All right, so for example, find the z-score that separates the top 1% of z-scores from the rest. So the top means to the right of it has to be 1%. So top is to your right. All right, but we need to know the percentage to the left of it. So we just apply the rule of complements, working in decimal here. So if 0.01 areas to the right, then an area of 0.99 would be to the left of that z-score. So you'll see on the picture that I didn't put any values on the number line. We don't have to draw perfect pictures here. I just want to get a feeling for if these answers will make sense. And we also interpret these graphs a lot moving forward. So we were looking for a z-score that separates the top 1% from the rest. So the top 1% would be somewhere with a z-score that would be positive, because let's get this information in. So if this area to the right is 1%, that's definitely less than half that picture, right? 1% is smaller than 50%. And that means that all of this area to the left of it, we wrote it in decimal 0.99, but that would be the other 99% of z-scores. Okay. So to use inverse norm, I'm going to do a little highlighting here. To use inverse norm to find z, I didn't mean to cross that out, highlight right there. So to find a missing z-score, I need to know the area to the left of the z-score, and then you inverse norm. So to find a missing z-score, I need to know the area to the left of the z-score, and then I inverse norm. So to find a missing z-score, I need to know the area to the left of the z-score. So if they don't give me the area left, if they give you area right, well, find the area left and then inverse norm. And that is basically all you need to remember. Inverse norm, area to your left. All right. And I'll see if my answer makes sense. 2.33, a positive z-score, matches what I expected. On my picture, I expected a positive answer, so that does make sense. Okay. So next one, find the z-score to the left of the mean such that 94% of z-scores lie to its right. All right, so let's put our mean in. So 0 is the mean for z-scores. And they say find the z-score to the left of the mean So there's going to be a z-score somewhere to the left of center. That's what I'm looking for. Such that 94% of z-scores lie to its right. So they're wanting that area to the right to be 94%. All right, so they want that area to the right to be 94%, 0.94. And we know that we need to find the area to the left using the rule of complements. So 1 minus the area to your right would be the area to your left. So 0.06 or 6%. And then once you know the area left of the unknown z-score, you just inverse norm. And we should get a negative number if our picture is correct. Looks good, negative 1.55. So that looks good. All right, so I'm just going to highlight that number of 6%. Okay, so this page is a pretty good summary here of what to do. So you can see that I've shaded the given information. So if you've shaded to your left, you just go right to inverse norm. If you have given information, the shaded areas to your right, then you still have to find the area to the left and then use inverse norm. And I encourage you to always draw a quick little sketch, even if it's by hand, without like a template to follow, to see if your answers are making sense. All right, and then we'll try to do a few more examples here and move forward.